This video is on solving systems of nonlinear inequalities. I recently did a video on systems of nonlinear equations. This one is based off of inequalities, which are less than, greater than, less than or equal to, greater than or equal to. If you remember back from graphing inequalities before, you have to make sure you have the solid or dotted lines and make sure you shade them accordingly, up or down. So what we're going to do is we're going to graph the inequalities, we're going to shade accordingly, and highlight the solution set. So to graph the inequalities, because we're dealing with nonlinear, we definitely want to get a table of coordinates so that we can easily graph them, because they're not always going to be lines to where you can graph nice and easily. So I'm going to color code my inequalities so that I can see the differences in my graphs. So my first one is y is greater than or equal to x squared. I'm going to graph that in pink. I'm going to put a little pink dot beside it, so that I know which one goes with which. I do know that this is going to be a solid graph because of the greater than or equal to, so I know it's solid. And because it's greater than, I know I'm going to shade up from the parabola. On my second one, I'm going to graph in my blue. I can also see that this is a solid line because it will be, or a solid parabola, since it is a parabola. It will be solid because it's less than or equal to. But because it's less than or equal to, it's going to shade down. So what I'm going to do is I'm just going to go into my table and graph these. So I'm going to graph this first one. I'm going to write out the list of points. Then I'll do the same thing with my blue and list out points. So I'm going to go to my y equals. I'm going to go to my y equals. I'm going to type in x squared. Now I do want to see I have a 10 by 10 scale, so if I can potentially get just count by ones, then that would be great, so that I could just keep working with smaller numbers. So I can go ahead and put my x on my x-axis and my y on my y-axis, and we'll look at our table to see if we can count by ones. Actually, we can go ahead and see if we can graph by ones. If we do 8 minus x squared in the second one, and then just look at the graph. So this is in a 10 by 10 scale as well, so this is definitely saying yes, we can look at 10 by 10 scale. So I'm going to show you how to look at them when you have both of them at the same time, but first I just want to make sure that we could graph them in a 10 by 10 scale. So I can do count by 1. So I know my graph is x squared, so I know we have this here. And it looks like my vertex is at 0, 0. And what I want to do is look at a table. So second table, I want to look at 0, 0, 0 does work, and I thought that might have been my vertex. And if you look, the y values around the 0, 0 are the same, so that means that 0, 0 is my vertex. So with that in mind, I'm going to take my pink, I'm going to put these coordinates, I'm going to put 5 coordinates in here. Now we can definitely graph more than just 5 coordinates on our plane, but I do want to at least have 5 coordinates. And I want to try and put if I have a vertex, put my 0, 0 in that vertex. So my 0, 0 is in the middle. And then I have, above this is -1 and then -2. I'm just looking straight off of my chart. Then I have 1 and 2. So at -2, it's at 4. And -1 is at 1. Therefore, these should be the same. So at 1 and then 4. Now, obviously, there are other ones that we can graph. So we can go ahead and graph these. We have at -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4. But there was also that -3, 9 and +3, 9. So +3, 9 and -3, 9. Again, the reason we do this is so we can have as many coordinates as we can, but we do want to list out some so that we can easily see them. So this is solid, so I'm going to go ahead and graph this. I'm not going to shade yet, because if I shade too soon, then it might be harder for me to graph the second inequality. So on the second one, I'm going to go back and type in y equals. I'm going to type in 8 minus x squared. Look at the graph. And it looks to be that vertex is at 0, maybe +8. So we'll look to see at second table, 0, +8. And if you see here, the y values are the same values on either side. that means that 0, 8 is in fact our vertex. So on our table here, I can put 0, 8 in the middle. So 0, 8, I'm doing this in that dark blue. So then I have -1, -2, and then I have 1 and +2. I'm just going from the table. At -2, it's 4, and then 7, 4, 7. So then I have 7, 4. Now obviously I can still graph these as well, so I can graph as many as I possibly can. So I'll go -2, -2 to +4. Then it's -1 to +7, 0, 8. Then I can see that I would have 1, +7, then +2, +4. So I have +2, +4, and I can see that these are parabolas will be crossing at these two locations. However, I want to keep going and get more coordinates, even though I can't write them. I can write them down, but I don't need to. So I can see at -3, -1. So 1, 2, 3, -3, -1. And let's see if there's any more that's possible to graph. So I can also see -4, -8, -4, -8. And the next one would be at all the way down to -17, so I know I can't graph that one. Now, because I have my vertex is along the y-axis, I can actually mirror these coordinates across. So I have 1, 2, 3, and then I can do 1, 2, 3. This one is 1, 2, 3, 4, 1, 2, 3, 4. So then I can graph this. Now again, this solid blue one was solid. So I can graph this solid, this parabola. Now that we have the graph, the inequalities, we want to shade them accordingly. So I'm going to go back to my pink one. So in order to shade this, I'm going to put my pink pen on the pink parabola, anywhere on that pink parabola. So I'll just do it right here. And it says to shade up. So I'm just going to draw a line up from here. What this does is tells me which half of the graph to do. So it's either inside the parabola or something outside of the parabola. Now as the line for the pink is actually inside the parabola, that means I'm going to shade all inside the pink parabola. It's the pink parabola. I'm going to do the same thing with that dark blue. So I'm going to put my pen on my dark blue, anywhere on my dark blue, and it says to shade down. I'm going to shade down. So again, it tells me if I'm inside the parabola or outside the parabola. Since what I just shaded was inside the parabola, I'm going to shade all the way inside of this parabola. I'm going to shade it lightly. I'm not going to be overpowering with the colors because I do want to see where they overlap because that's what our solution is supposed to be. So you can there's no shading over on this side, on the left, no shading on the right. There's only blue underneath the x-axis, and the pink is up in here. But as you can, hopefully you can see right here, we have blue and pink intermingled right here. So that's our solution set. So I'm going to highlight the solution set. This is our solution set inside these two parabolas. That's our answer. 2 parabolas. On this next one, I'm going to go down to number 2. And this one is a radical and then a parabola. So again, this is nonlinear. So I'm going to go to my y equals. And I want to show you how to do this by seeing both equations at the same time and getting both coordinates. So I'm actually going to type both of them in. Actually, I'm going to do this is going to be, it's in y format. So this is going to be a dash because it's just less than. This is a dashed graph. But it does say less than, so I will shade down. And then for the dark blue, this is also going to be a dashed parabola. But it says greater than, so it will be shading up. So for these, I'm going to type in -√of x, close parentheses. Then on the second one, I'm going to type in x² minus 7x plus 3. I'm going to look at the graph real quick to make sure I can do count by ones. There's the radical, and there's the parabola. So they actually cross twice, just as you can see that. So it looks like I can graph both of those on a 10 by 10 scale. So I have an x-axis, a y-axis, and I can count by 1. I'm going to put CB1. Now what I'm going to do is get the coordinates for these. So for the pink one, that's the radical. That was actually the first one we did. So if I press second table, this time I have x values, but then I have a y1 and a y2. If we look back at our y1, this was specifically for our radical. That's our pink one. That's what I'm going to look at. So I basically just cover up my y2 and don't look at that one. I still want to have the x values. Now -5, there's an error because the graph didn't go to the left. It started at 0, 0. So all these errors I can't use. So again, if I basically just cover up this y2, I don't want to look at it. I have all those errors on there, so I'm going to go to my first coordinate. This is called your key point. This is our first coordinate we're actually going to write down, and we're going to graph that one. This is at 0, 0. The second one, that's a good one, is 1, -1. Then we have 2, and then it's a decimal, so let's see if there's anything else. There's 3 decimal, 4. 4 is at -2, so that's a good one. We can graph 4 and -2. We keep going, see if there's any other good ones. Then we have 9 and -3. Let's see if there's another good one. It might be over 10, but that's okay. I just don't want to write down those coordinates. It's at 16 and -4. Now, if you think about it, these numbers are, you can take the square root of 0, 1, 4, 9, and 16, which is why that happened. It's actually technically the negative square root of 16, so it's negative times the square root of 16 is 4. It's negative times 4, which is why that happened. So then if we want to get our blue, I can do the same thing, but this time I want to cross out or cover up my y1s. So I don't want to see those if I can. So these coordinates right here, this x values of 10 and these y values are way too large. So I want to scroll up until I get to some better coordinates. I want to see if it's possible to find the vertex. Now, if you look right here, do you see how it starts at -9 and then goes back to -9? That means our vertex is actually somewhere in between that value. So this would actually be a good setup to use these coordinates right here. So in my dark blue, I'm going to go towards the middle. I'm going to have my -9s in the middle. So I want my -9s to be really we can have those -9s in the middle somewhere. I can do 1, -3 up here, 1, -3, then 2, -7, 3, -9, then 4, -9, then 5, -7, and then 6 would be at -3 again. Looks like 7 is at +3, so we can graph even more. So that's helpful when we're going to be graphing them. So our pink is at 0, 0, 1, -1, 4, 1, 2, 3, 4, -2, 9, -3, and I'm not going to go further off that, but I do want to put it is dashed, so I do a dashed, and I do put arrows. Then for the blue, I'm going to do the same thing, so 1, -3, 1, -3, 2, -7, 3, -9, 4, -9, 5, -7, and I can actually go more and do a mirror of that one. Also have it at, it's like 7 and +3. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, +3. Let's see if there's any other ones. At 3, +3, and then we have 8, 11. So I can go a little off the graph here, 8, 11. And I just want to mirror these. So we have at 0, +3, and then we'd have -1, 11. These are all the same distance. Now this is not your vertex. You do not draw a line down here. This is still supposed to be a parabola, so it's supposed to curve. Okay, be careful about that. And this is dashed, so dash it as best as you can. And then put arrows. So now is when we shade it. Now the shading of the radical is a little tricky because the shading, you cannot go on this direction because it never went over here. So we're going to shade again up and down. So the graph on the pink is shading down. So that tells me that I'm doing the bottom half of the pink. But because of this, I can't go over into these quadrants. So my pink actually has to stay in technically only in the fourth quadrant. Only go in the fourth quadrant. The blue is asking us to shade up. So from my parabola, am I going to shade inside the parabola or outside the parabola? So with the blue, I'm going to shade up, which is inside the parabola. So I'm going to shade in the blue inside the parabola. And again, I want to find where they crisscross, where the blue and pink meet, and it's inside the parabola underneath the radical. So I'm going to highlight this location. Now remember that since it's a dashed line, that these coordinates are not part of the solution set that are on the parabola and on the radical, but anywhere inside the middle of that would be a solution to it. On number 3, I'm coming up here, we have a parabola and a line. So the line you can actually graph without having to do your table, but you still can. So we're going to go to the table, y equals, I'm going to clear these out. Since they're both in y format, we're good. I can see that this one is going to, it's less than, so it's just going to be a dashed. And it says less than, so it's going to go down. And then for the line, it's going to be solid. And it's going to shade down as well. Sorry about the bell. So we want to graph these. So x squared plus 3x plus 2. And then x minus 5. Graph it real quick to make sure it's in a good table or in a good graph. And actually we can see that the graphs won't cross, but again, these are inequalities, so the shading might still cross. Okay, so we can do a 10 by 10 scale. So we have an x-axis, a y-axis, we're going to count by 1. So for the pink, for the parabola, I'm going to go to my second graph, and my parabola was the y1s. So if I don't look at the y2, I want to look at the x's and y1s. So then these coordinates, these y's are not good. So I'm going to scroll up until I find a good values. These values are actually pretty good, and you can see that 0, 0 repeats right after each other. That means our vertex is actually somewhere in the middle of those. So we can actually use these coordinates. So negative 4, 6. I'm going to use negative 4, 6. Negative 3, 2. Negative 2, 0. Negative 1, 0. And 1, 6. Oh, sorry, 0, 2. 0, 2, and then 1, 6. For the blue, because it is a line, we can graph that. We know we will start at 0, negative 5, and that is at 0, negative 5. So you can still write those coordinates out. So I can write out any of these. So negative 4, negative 9. So basically you cover up the y1s. You don't want to use those. So we have negative 4, negative 9. I'll put negative 4, negative 9, negative 3, negative 8, negative 2, negative 7, negative 1, negative 6, 0, negative 5. And obviously we can still keep going with the slope. So now with our coordinates, our pink is at negative 4, 1, 2, 3, 4, positive 6, 1, 2, 3, 4, 5, 6, negative 3, 2, 1, 2, 3, 1, 2, negative 2, 0, negative 1, 0, 0, 2, and then it would be at 1, 6 because that would be a mirror image of each other. But again, this is a parabola, so it does actually curve down. Okay, so be careful about that. It is dashed. And make sure you put arrows at the end. I'm not going to shade yet. So then the dark blue, I can just graph these coordinates, or I can use my 0, negative 5, 1, 2, 3, 4, 5, and my slope is up 1, right 1. So I can draw as many points as I can, and this will be a solid line. And again, these graphs won't actually cross the actual graphs, But since we're dealing with inequalities, we have to worry about where will the inequalities cross. Where will the shading cross? So with the pink for the shading, on my pink parabola, I'm going to shade down. And we're either inside or outside the parabola. And as you can see, it's outside the parabola. So I'm going to shade everywhere outside the parabola. Everywhere outside of the parabola. And that means everywhere. So even down into this, to the bottom half of the graph, I have to shade everywhere outside the parabola. Now for the line, I'm also going to shade down. So I'm going to, in my blue pen, I'm going to shade down. This is the bottom half of the graph, all the way along this blue line. And since even though the graphs didn't cross, the inequalities do. The inequalities actually graph everywhere underneath the line. So basically, everything underneath the line, this is actually your solution. Every single thing underneath that line that's less than that line. And this does go on forever. So when inequalities, again, just because the graphs don't cross doesn't mean that the inequalities won't. Doesn't mean you won't have a solution set. So on number 4, we have a radical and another line. So on the radical, we do want to see if we can graph this by a 10 by 10 scale. And these are in Y format, so we can say the pink is going to be a solid graph. And it will shade down because it's less than. The second one is going to be a dashed line. And it will shade up. Again, sorry about the bell. So on the y equals, I'm going to clear these out. We have the square root of x plus 1, and those are both inside the radical, so I have to make sure I close my radical after that. And then I have to put the minus 7. Then I'll have the x minus 5, and again, the x minus 5, we don't have to put the coordinates, but we can. We'll graph this. And this is in a 10 by 10 scale, so that's good. Now again, the graphs don't cross themselves, but that doesn't mean that the shading won't. But do you notice with the radical, it doesn't extend further? That's why with the shading, we have to be very careful and not extend it any further. So we can count by ones. This is an x. This is a y-axis, and we can count by 1. So for our pink, that's the radical. The key point, the actual one that we want to start with, it looks like it's at -1 and then -7. And if we look, we actually change the sign inside of here, just like in vertex form. That becomes a -1 and then a -7. So if we look at our table, we have -1, -7 for our radical is actually our first coordinate. So that's one we want to use. So -1, -7 is the first one we put on here. -1, -7. Then we find another good one, which is at 0, -6. See if we can find some other good ones. 3, -5. Then we have 8, -4. So we can find one more good one. Might not be able to graph it, but we'll still write it down. 15, -3. And then for our dark blue, again, it's x minus 5. So we can graph any of these coordinates. So we can do 9, 4, 9, 4, 10, 5. Then 11, 6. Even though this is outside of the 10 by 10 scale, we can still graph this like a normal line and just use our slope-intercept form. So now with the pink, we have -1, -7 is our first coordinate, 0, -6, 3, -5, and then 8, -4. This is solid radical, so we'll keep going. Not going to shade yet. Then the blue is, again, I can just graph this, go to 0, -5, 1, 2, 3, 4, 5. My slope is up 1, right 1. So the same as the last one, it's just now that this is going to be a dashed line instead of a solid, and it's shading differently. So now, dash line, since I have so many coordinates, I can connect just every other one. And just extend it. Now I'm going to shade. So with the pink, I'm going to shade down. So it says underneath the radical. Now because I am shading down, or because I'm shading radical, I can't go past this value over here, so I'm basically going to stay mainly just inside the fourth quadrant. I'm a little in the third quadrant, but that's it. And then for the blue, we're going to put the blue pen. It's going to shade up. That's actually the upper half, so I'm going to shade above this line. So again, even though the graphs did not cross themselves, we got to check to see if our shading crosses, because with inequalities, you could have solutions even though the graphs don't cross. Now we have all blue over here, nothing here, and all green. Nowhere do both of the inequalities cross, nowhere do both of the shadings cross. So in this case, even though, again, the graphs don't necessarily mean that they won't have solutions, it's the inequalities themselves and the shading. So because the shading's not intersecting at all, then that means that we do not have a solution. So our answer here is no solution. So I'll highlight that because our answer is, in fact, no solution. So these were solving systems of inequalities, nonlinear inequalities. We had parabolas, lines, radicals. These you want to, again, still find where they intersect, where the shading intersects.